Hi, in this video we're going to be going over two-dimensional arrays in Java. So a two-dimensional array is a lot like a one-dimensional array, which is really just a list. So it's a list of items. And for a 1D array, it's just a one-dimensional list, meaning that it's just one column of data. A two-dimensional array can be thought of as a table of elements. So it's got rows and columns to it. So another way to think about a two-dimensional array is that it's a list of lists. So if you had a list, and then within that list you had individual lists as items in your list, then that would be a two-dimensional array. So it's an array of arrays. So a two-dimensional array is declared by specifically giving its size in each dimension. So for example, int bracket 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 bracket. This is telling me that it's of type integer 2D array. So this is a two-dimensional integer array. The variable name is scores. We use the new operator to initialize it. And then int 12. So 12 is, this is an example of the number of rows. And then 50 is the example of a number of columns. So what that means in terms of rows and columns is basically we're saying that in our array of arrays, our outer array is going to have 12 individual arrays inside that array, all with 50 items in it. So we have 50 item lists inside of a list, and we have 12 of those 50 item lists. A two-dimensional array of elements is referenced using two index values. So we have an index which deals with the row, and then an index which deals with the column. Or really it's the index of like which row number there is. So bracket 3 would be the fourth row, and then bracket 6 would be the seventh column. So fourth row, seventh column. And then to modify an array element, we can just use the equals operator. So we don't have to use any methods like get or set to access values. We can just say scores, bracket 4, that's the fifth row, bracket 8, which is the ninth column, because our index values start at 0, is equal to some value. So we can just reset whatever it was. So say that value was 10, we can set it to some other value. Say we can set it to 20. And that's how you would change the element. So these are the different expressions that you'll see. Scores would be just the variable name. So that would be the type 2D integer array. So this is a list of lists or an array of integer arrays. And then scores bracket 5 would be the sixth row of your two-dimensional integer array. And scores bracket 5 would return an integer array because it's the integer array that's within, one single integer array that's within your two-dimensional array. And then scores bracket 5 bracket 12 gets you a specific integer value at a specific row and column. So two-dimensional arrays can be initialized using int bracket 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 scores equals. We can just list out the elements. So we don't have to specifically initialize it by just saying how big it's going to be. So for example, like this, we can also set it equal to an array literal, meaning like exactly how we want it, like all the numbers inside of it, we can just set it equal to exactly what it's going to be. So for example, when we do this, we can only do it while we're initializing the array. So here, if I did, instead of scores equals new int bracket 2 bracket 3, I could instead say int bracket bracket scores equals, and then I could specify the exact values it's going to be. Notice this is our inner list or our inner array, and it's an array of arrays. So there's 2 arrays within our larger array. Since two-dimensional arrays is implemented as an array of rows, where each row is a 1D array, then scores.length represents the number of rows in the two-dimensional array. So scores.length is not all of the total number of values in your array, it's just the total number of rows. So scores.length is the total number of rows in your array. That's really important to know. And then scores bracket k.length is the number of columns in your array. So think of that as it's the size of each array within your array. Okay, so it's the size of each one. Now, in AP CSA, we're only dealing with rectangular arrays, meaning that scores bracket 0 is going to have the same length as scores bracket 1, as scores bracket 2, as scores bracket 3, as scores bracket 4, because every single array within the array is going to have the same size. Hence, it's going to be rectangular. So really, k can be any row number, and then this gets you how many columns there are. So if we were to loop through a two-dimensional array, we can use a nested for loop. So here's an example where we're saying for int r is equal to 0, and r is a good variable to talk about the rows in your array. R is less than scores.length. So scores.length is the number of rows in your array. And then for int c equals 0, to c is less than scores bracket r dot length. Now bracket r could be replaced with bracket 0, bracket 1, bracket 2, whatever, as long as that r value is within the range of how many rows there are. So this basically just gets the number of columns. And then system out print line, this gets you the specific value at that row and that column. So this is the value. This over here is the number of columns. And over here, this would be the number of rows. Looping through all the elements, you could also do this by using an enhanced for loop. So this is not in the AP subset, but you can use it on an FRQ. And what's nice about an enhanced for loop is that you don't have to deal with all 3 different sections of your for loop. You don't have to do your stepper variables, meaning int r equals 0. So this is a little bit cleaner, but it's also not as useful when you're trying to access the index value of an array. Because here we're just straight up looking at each row and then an element in a row. So if we only know the element value, then we don't specifically know its index, unless, of course, we get the index using some other method. Replacing an array element. So in order to replace an array element, so say we want to replace a whole row of our array with a different row. So say we have a two-dimensional integer array called scores, and it has these scores, it's initialized to those scores. You must define a new array in order to set this new array equal to something else. So for example, if I did something like scores bracket 0, so I want to set scores bracket 0, which is just this portion, right? That's scores bracket 0. If I wanted to just set that to 9, 9, 9, this will not work, because this is just literally what the array should be, but arrays are objects. So if this is a new array, then we need to use the new keyword. So instead, I would either do int bracket bracket temp equals this, 9, 9, 9. And in this case, we don't have to use the new keyword because we're declaring a new integer array here. Or we could do scores bracket 0 equals new int bracket bracket and then 9, 9, 9. So these are the only two things that work if we wanted to replace a whole row of an array, of a 2D array. So things that you definitely need to know for the AP. 1D arrays are definitely part of the AP Java subset. Both arrays of primitive types, aka int, double, and arrays of objects like student or car or circle are in the subset. Initialization of the names, so knowing how to initialize a 1D array. Two-dimensional rectangular arrays are part of the AP subset. So you need to know a 2D array as long as it has the same number of columns and rows in each section. Students are also expected to know that array bracket 0 dot length is the number of columns in a rectangular two-dimensional array. So again, something that's not tested would be an array that is like a three-dimensional array, and also an array that has an uneven number of rows and columns. So if you had an array with the inner array having 4 items, and then the second one having 2, and then the third one having 3, that wouldn't be tested on the AP test. So now that you've watched this video, you're going to take a Google form, which is just a quick check for understanding to see if you know the basics of 2D arrays. And that's it.